Assalamualaikum and hi everyone. So welcome to our video on humidification and its application. So we are from group 1 in session 1 SETK 3323. First, let's talk about chemical engineering. So it's the field that combines chemistry, physics and also math to design processes that turn raw materials into useful products like fuels, medicines, clean water and many more. To do this, the engineer rely on unit operations, the basic building blocks of every chemical plant. One important unit operation is humidification. It means the addition of moisture or water vapor to air or gas. The opposite is dehumidification, which means removing the moisture. And you can see these processes in our everyday life, from activities like drying our clothes, feeling sticky in humid weather, or enjoying cool air from the air conditioner. So here is the key definitions. Firstly, humidity is the amount of water vapor in air. And next, relative humidity tells us how full the air is compared to its maximum capacity. And last but not least, percent saturation shows how close air is to being fully saturated. So to measure the humidity, we use two temperatures. First, dry bulb temperature, which is the normal air temperature, and second is wet bulb temperature, which is measured with a wet cloth on the thermometer, where the evaporation cools it down, and the difference between them tells us how humid the air is. The engineers use the psychometric chart to read the air properties, and the x-axis shows the dry bulb temperature, the y-axis shows the humidity, and the curve shows saturation and also wet bulb lines. It's like a map that helps us to design the cooling, drying, and also humidification systems.
Hi, my name is FIRHAD. Now let's see the core theory of humidification and dehumidification. So for the continuous humidification process, it will occur when warm water contact with unsaturated air. So the water will evaporate into the air. Then the latent heat of the vaporization is absorbed from the water. So this will cause the water temperature to decrease. In adiabatic saturation process occur without heat exchange with surrounding. So we can see that the heat lost by water is equal to the heat gained by the air. So the water can only be cooled into the wet bulb temperature. In the physical mechanism, humidification is water transfer from liquid phase to the gas phase, and the dehumidification is water vapor transfer from the gas phase to the liquid phase. So we can note that in humidification, saturated air absorbs water vapor. So since evaporation needs latent heat, so the water will cool down naturally. Now let's see the water cooling tower, which is the back tower. So how cooling tower works? Warm water flow downward and the air flow will flow upward, which is counter current flow. So the water evaporates into the air and then the remaining water will become cooler. And we can see that the flow arrangement here, hot water will go downward and the air will go upward. So the counter current will improve the heat and mass transfer. So the main principle here, we can use the water cooled by evaporation and the air become humidified, and this also show that it is adiabatic process. So the water usage usually can be discharged to the river or recirculated and reused. So the cooling tower is basically a humidification tower where the water is cooled. Now let's see the type of cooling tower. First, natural draft cooling tower. Usually it uses natural air movement due to the density difference. So there is no fan required and the lower operating cost. Second, for the forced draft cooling tower, fan will push the air into the tower. So it will provide a better air control and become more compact. And third, the induced draft cooling tower. So fan will cool air from the top and then the better airflow will distribute and it requires a higher efficiency. So for the comparison, we can see that for natural draft, the air movement is natural convection, so the energy used is low. And for the forced draft, fan will push the air, and then the energy used is medium. For the induced draft, fan will pull the air, so the energy used is higher. So we can note that the main difference between this system tower is how the air moves through the system.
And now we will go to the application of humidification process. Firstly, humidification refers to the process where water evaporates into the air, increasing the moisture content or humidity of the air. One of the most common industrial applications of humidification is in cooling tower systems. In cooling tower, water evaporates into the air to remove excess heat from industrial process, and the cooler water is then recirculated back into the system. It is also can be operated as air conditioning system by cooling hot water through evaporative cooling. The application of cooling tower system are widely used in various industries such as power plant, petrochemical and chemical industries, refineries, HVAC systems, in large building and manufacturing industry including steel and cement plants. This application demonstrates the importance of humidification in maintaining efficient industrial operation. For the further applications, besides the cooling towers, there are several applications that is widely used that involve with humidification process and applied in many other industries. For example, in heating, ventilation, air conditioning which is HVAC system, humidification helps maintain comfortable indoor humidity levels and resulting in improved thermal comfort and better indoor air quality. In the textile industry, humidification reduces static electricity and prevent yarn breakage which improve the fabric quality. Meanwhile, in the paper and printing industry, it helps maintain the moisture content of paper, reducing problems such as curling and cracking. Furthermore, in the pharmaceutical industry, humidification provides controlled environmental conditions to ensure drug quality and stability. Meanwhile, in the food industry, it minimizes moisture loss during the process and storage, and leading to better food quality and extend shelf life. In the conclusion, understanding humidity and temperature parameters is essential for controlling humidification process effectively. The psychometric chart is also an important tool for analyzing air properties and designing humidification systems. Most importantly, humidification plays a significant role in maintaining suitable humidity levels, improving operational performance, enhancing energy efficiency, and preserving product quality in various industrial and commercialized applications.